Welcome back, everyone. We're on day 25 out of 50, officially halfway done with our Road to a 750 plus math series. And today we're going to be solving more problem solving and data analysis problem types. Looking at our first one, we have this one over here. It's about blood type, and I don't even know how to pronounce that, but rhesus factor. Let's say it's pronounced like that for this video. Okay, human blood can be classified into four common blood types: AB, AB, and O. It is also characterized by the presence or absence of the rhesus factor. The table above shows the distribution of blood type and rhesus factor for a group of people. If one of these people who is rhesus negative is chosen at random, the probability that the person has blood type B is 1/9. What is the value of X? Okay, so looking at this last sentence, that's really when you're going to get all your information from these passages. If one of these people who is negative is chosen at random, so we know that they're negative type, so this is our probability. So the total for this, I'm going to write a little total subcategory right here. You know that the total is X plus 1 plus 2 plus 7. That's the total amount of people for this category. So now, with that in mind, we know that this probability is equal to 1/9. So what we're looking for is the probability that the person has blood type B. So 2 over our total, X plus 1 plus 2 plus 7. And now we're going to solve for our X value. So we cross multiply. This is going to be all one expression. So it's going to be X plus 10 is equal to 18. And X is going to be equal to 8. If you got lost here, I just added this part before switching it over. So yeah, that's your answer for this question. Okay, so we know that our percent change formula is equal to new minus old divided by old times 100. And given our 2 points, 2003, 40, and 2007, 10, we know that this is our old value, this is our new value. So new, so we have 10 minus 40 over 40. We're only looking at really these points. It's not slope. Times 100, which is equal to negative 3 over 4 times 100, which is equal to negative 75% change. And since p% is the percent decrease, we ignore the negative. So it's just going to be a 75% value for p. And when you put it into the computer, well, also since it says is the percent decrease, you wouldn't write percent here. But regardless, you would never put percent into the computer for your answer choice when it's a fill-in question like this. So p is equal to 75 in this question. Okay. Next, we have a study was done on the weights of different types of fish in a pond. A random sample of fish were caught and marked in order to ensure that none were weighed more than once. The sample contained 150 largemouth bass, of which 30% weighed more than 2 pounds. Which of the following conclusions is best supported by the sample data? These types of questions, when it gives you options, just read the options, go one by one, cross it out, or underline if you think it's a possibility. The majority of all fish in the pond weigh less than 2 pounds. Okay, that's a possibility. The average weight of all fish in the pond is approximately 2 pounds. Okay, it gives us nothing about an average here, only says 30% weighed more than 2 pounds, so that gives us no information alluding to the average. Approximately 30% of all fish in the pond weigh more than 2 pounds. So that is also very close to correct, or a possibility in my opinion. So approximately 30% of all largemouth bass in the pond weigh more than 2 pounds. Okay, so reading this answer, it immediately makes me certain that A and C are correct, because looking at A, the majority of all fish in the pond weigh less than 2 pounds. We aren't testing a sample of all fish, we're testing a sample of 150 largemouth bass. And then for C, approximately 30% of all fish in the pond weigh more than 2 pounds. Same thing of all fish in the pond. No, only largemouth bass. So that's going to leave us with D as our answer. Okay, next problem. Pure beeswax has a density of 0.555 ounce per cubic inch. An online company sells pure beeswax at a price of $8 per ounce. What is the selling price in dollars per cubic inch for pure beeswax purchased from this company? So selling price in dollars per cubic inch. This is going to be some stoichiometry here. So we're going to write our expressions out. So we need dollars in the numerator, cubic inches in the bottom. So we have this over here. We have $8 per 1 ounce. Then we need to multiply that to get rid of ounces and introduce cubic inches in the bottom. So we know that 0.555 ounces contains 1 cubic inch. The ounces cancel, and then you're left with 8 times 0.5555. Use your calculator, and you get 4.44. And that's your answer. This is another fill-in question, not too difficult. Just know how to manipulate your ratios. Okay, final question of the day. This is the hardest one we've had in a while. So just a heads up. Years and then subscriptions sold, that's our chart. The manager of an online news service received the report above of the number of subscriptions sold by the service. The manager estimated that the percent increase from 2012 to 2013 would be double the percent increase from 2013 to 2014. How many subscriptions did the manager expect would be sold in 2014? Okay, before we dive in, we need to really dissect the wording in this problem. So 2012 to 2013 would be double the percent increase from 2013 to 2014. So we know that in 2013 to 2014, in other words, the percent increase would be half of that seen in 2012 to 2013. So this jump would be half in value. Okay, so looking at this, we are going to start by finding the percent increase for subscription sold from 2012 to 2013. So percent change. And we know that's going to be equal to new, which is 5,880, minus old, which is 5,600, over old, which is 5,600, times 100. And that's going to be equal to, put that in your calculator, 5,880 minus 5,600 divided by 5,600, all times 100, and you get 5. So there's a 5% increase. I'm just going to write increase here so you don't get confused. So we know from here to here, to get 5,880 from 5,600, a 5% increase can be denoted as multiplying 5,600 times 1.05, because this is the decimal version of a 5% increase. Now we're going to do the percent increase for 2013 to 2014. Make yourself a little chart here. And we know that it is half the increase seen from 2012 to 2013, since it has doubled the percent increase in 2012 to 2013. So we know that there's going to be a 2.5% increase. And that is symbolized as 1.025. So we know that 5,880 times 1.025 is going to give us our 2014 subscription sold value. So 5,880 times 1.025 is going to give us 6,027, which is answer B. The only really tricky part of this problem is if you don't know percent change, obviously percent change, but if you do, the only abnormality to this problem is the wording here. It says double the percent increase, and the first time I did this, it threw me off, and I did 1.05 to then 1.1 instead of 1.025. I doubled the original value. So make sure you're reading your question very carefully, and you see that it is kind of asking you in a reverse way. So thank you for joining me again. I hope this video helped, and please subscribe.